Hi, the section 3E, the block payments. So example, suppose that the payment amount that depends on the year, and it's as follows. So for the first year to 10th year, that we have $5 a year. And 11th to 18th year, that we get $12 per year. And 19th to 23rd, the $10 each. And the 24th to 30th year, the $13. So this is an annuity for 30 years, but the payment amount that depends on the time point. So variable. So we want to calculate the present value that when I is equal to 3. Okay, so we start with the time diagram. So we have 30 years. So yeah, it's complicated. So we start at 0, and the first payment is at 1, and 1 to 10, we get $5. So $5. So yeah, maybe I will just write the $5 here. 5, 5, 5. And 11th to 18th year, that we received $12 each. And 19th to 23rd, $10 each. And 24 to 30, 30, that we get the $13 each. So there are several ways to calculate the present value. Yeah, present value. But yeah, for example, we have, okay, so we have the 4 blocks. So if we calculate the one by one, the 4 blocks, and we calculate the present value, then we can certainly get it. But here, that we just think about one trick, and we just make this as just the addition and the subtraction of the usual annuity immediate. So the technique is that we think about the longest cash flow first. So the longest cash flow, okay, so the further away payment is $13. So we think about the $13 payment, $13 payment for 30 years first. So basically we match the numbers from 24th year to 30th year. Yep. Then, okay, so now that we matched this portion, so we matched this portion. So now we want to match this portion. So $10 for 19th to 23rd year. So that is $3 less than $13. So we think about the -3, the cash flow of -$3 at each time point from 1 to 23rd. Then if we think about the total, 13 minus 3, then that is equal to 10. So it matches with this, the $10. Then we go backward to continue. So we have $12 here from t is equal to 11 to 18. So we have to add $2. So we think about the $2 each. Then finally, then we have $5. That is the $7 less than $12. So we subtract 7. So -7 from 1 to 10. Then each part matches each block. And now that we think about the present value of each line. Okay, so this the 1, 2, 3, 4. The first one is $13 for 30 years, the present value of that. So that means the present value is 13 times a right angle 30. So present value is equal to the 13 times a right angle 30 at this I is equal to 3%. Then second one, so this is the first one. So second one, the negative 3 times a right angle 23, because this is the $3 payments for 23 years. This is number 2. And the third one, plus the 2 times a right angle 12, and minus, so this is the third one, and the fourth one, 7 times a right angle 10. So this amount is equal to PV. So now that we can apply the formula, or that you can calculate the each quantity by BA2 plus. So if we use the formula, this is the 13 times 1 minus v to the power 13 over I minus 3 times 1 minus v to the power 23. Sorry, this is v to the 30th power 30 over I, and plus 2 times 1 minus v 12th over I minus 7 times 1 minus v 10th over I. And here the v is equal to 1 over 1 plus I, so that is 1 over 1.03. So this is equal to 0.97087. So slightly larger than 0.97. So if you plug in numbers, then you can get this first quantity as 254.81, the second quantity 49.33, and the third quantity 27.51, minus the first one, 59.71. So in total, this becomes $173.27. Yeah. So what's the total payment? Total payment is the 10 times $5. So this is 50. And 12 times 8, so 96. And the 10 times, okay, 19 to, so the 5 times, so 50. And the last one, the 13 times 7, so it's 91. So in total, that we have 50 plus 96 plus 50 plus 91. So that is 287. And we have a discount because we calculate the present value. So 173 is kind of reasonable. So this is the solution. Yeah, so, okay, so there are several ways to calculate present value in this case. Maybe you can think about each block, the block of $5, block of $12, $10, $13. But actually for this specific question, the easier way is our solution. So we think about the longest sequence first and kind of going backward, and to decompose this PV into 4 different annuities. So in short, to calculate PV of the block payment, the block payments, they start with the longest cash flow. So we start with the longest one for 30 years, $13 for 30 years. Then they go backward. So go backward to have shorter annuities. Okay, so this is the first example for the block payments.